Hi, and welcome back. So let's do another one of these calculus final review problems. So in this video, we're going to take a look at the function f of x is equal, there it goes, f of x, let me rewrite that, f of x is equal to e raised to the 8 times the square root of 7x plus 12, all of that divided, so all of that divided by x minus 6 raised to the 9th power. So this is the function we're going to work with, and all we're going to do is we're going to try to find the derivative of this function. So if you want to, that's the problem. So if you want to pause the video and try to figure it out on your own, and if you haven't done that yet in the playlist, I'd recommend maybe starting now, starting to pause the videos and try to figure out the answer before I just start working through it. So anyway, now I'm going to assume that you've unpaused the video, and I'm just going to start working through this. So the first thing to realize about this problem is that we could definitely solve this problem by using the product rule and using the chain rule, and we would rewrite it a little bit. We would write this as x minus 6 raised to the 9th power, or we would write this as instead of dividing by x minus 6 raised to the 9, we would multiply by x minus 6 raised to the negative 9, and then we could use the chain rule and the product rule and everything to figure out what the answer to this expression was. But one of the things to notice is that if we did that, it would take us a really long time. So if you see something like this on a final exam, you should have bells and whistles going off in your head that are just screaming to use logarithmic differentiation. So I'll just write over here, log diff, for logarithmic differentiation. So I'm going to go through this kind of quickly, but the first thing we do with logarithmic differentiation is we are going to start off by taking the natural log of both sides of this expression. So we are going to have, over here, we'll have the natural log of f of x is going to be equal to the natural log of all of this stuff, of e to the 8x times, and I'll rewrite this, times 7x plus 12 raised to the 1/2. Raising something to the 1/2 power is the same thing as taking the square root, and then dividing it by x minus 6 raised to the 9th power. So now we've done that. We've taken the natural log of both sides. What's the next step for logarithmic differentiation after we take the natural log of both sides? Well, we're supposed to simplify this side that I've got in green over here. We're supposed to simplify this using some of our properties of logarithms, right? So actually, right now I'm going to erase this. I think we know that we're using logarithmic differentiation, so I'll erase that. And up here, I'm just going to write down some of the properties of logarithms, or at least the properties of logarithms that we're going to use in this video. So the first one is if we took the natural log of some function where we had some expression a times some expression b, what can we rewrite that as? Well, we can rewrite that as the natural log of a plus the natural log of b, right? So we can split this up. Instead of saying the natural log of a times b, we can say the natural log of a plus natural log of b. How about this one? If we had the natural log of a divided by b, what can we rewrite this one as? Well, this one is going to be, you can probably guess what this one is, natural log of a minus the natural log of b. And that kind of makes sense. I mean, you know, we could say that we're multiplying by the inverse of b, so it makes sense that we would be subtracting it out. And then the last one, which might even make even more sense because we were subtracting the inverse of b in this property, and hopefully you've seen these properties before. I'm going through them pretty quick. The last property is that if we took the natural log of some expression a raised to a power, we're just going to say some power n. So if we took the natural log of some expression a raised to the power of n, we can just bring this exponent out in front of our logarithm as our coefficient, right? We can say that this is going to be equal to n times the natural log of a. So these are the properties of logarithms. Probably these are most of the properties of logarithms you'll need, at least for Calc 1. But these are the properties of logarithms that we are at least going to use in this video. So now, how are we going to use these properties of logarithms to simplify this expression I've got down here in green? Well, we're going to start out, and let me switch colors again. So we're going to start off, and actually, you know what, I'll just write, actually, yeah, I should keep my natural log of f of x right there. We're going to start off, so we've got the natural log of e raised to the power 8x. That's the first expression that we would have. So we have the natural log of e raised to the power of 8x. And now you can see which expression or which property of logarithm can we use to simplify this expression a little bit. We can use this one right here, right? This exponent property. So we can rewrite this, and I'll just use the eraser. So erase the 8x there, and instead just have the 8x come out in front of our logarithm, right? And even you can see the natural log of e. We'll simplify that a bit more in a second, but hopefully you can see that that does simplify a lot. So anyway, we've figured out we've got, that's our first term in this simplification that we're doing. So now how about the next one? Well, we're multiplying these two together, right? We're multiplying e times 8 at e raised to the 8x times 7x plus 12 raised to the 1/2. So which property can we use to write our next term? Well, we can use this one, right? Because we've got the natural log of some expression a, so our e to the 8x would be our a, and our 7x plus 12 raised to the 1/2 would be our b in this expression, right? So we are going to be able to write this, and then before we write it, well, actually I'll just go ahead and write this. We can say the natural log of 7x plus 12 raised to the 1/2 power, right? I'll draw that 1/2 better. Raised to the 1/2 power. And now, hopefully you can see that we can use this exponent rule of logarithms again, right? So we can have this 1/2 power. I'll go ahead and erase that. There we go. We can have this 1/2 power become our new coefficient in front of our logarithm, right? So now we've got 2 out of 3 terms done for this expression. So now what's our last term? What's our last term that we have to put in? Well, it's this term, right? It's x minus 6 raised to the 9th power, and we're dividing by it, right? So you can probably guess we're going to use the one property of logarithms that we haven't used yet. We're going to use the natural log of a divided by b is equal to the natural log of a minus the natural log of b. So therefore, because we're dividing by this entire expression, we're going to subtract. We're going to subtract out the natural log, and I'm actually going to go ahead and write my exponent as my new coefficient right now. So we're going to be subtracting out 9 times. Actually, I'll keep my usual convention, write it in this toxic waste green color I've got. So we've got 9 times the natural log of x minus 6. So now we've pretty much simplified this expression almost as much as we can. There's one other thing that we can do, and hopefully you can see how can we simplify this term, the natural log of e. Well, that's pretty simple, right? The natural log is just we're asking if we take the natural log of some expression, we're pretty much asking e raised to what power would give us this number. So the other way, if we say the natural log of e, what we are asking is when we raise some number to a power, or what power, when we raise e to what power do we get e? I know that might be hopefully that's not too confusing, and hopefully this is also a review. But hopefully at the same time you can see that in order for us that the power we raise e to in order to get e is just 1. The natural log of e is equal to 1. So therefore this term just cancels. It's we don't have to worry about it. So actually I'll just go ahead and erase. Hopefully I didn't confuse you with that last sort of side note. So I'll just erase all that, and then I'm going to keep my 8x right there. So now we've got everything simplified out, and we are at the point where we can actually take the derivative of this expression. So let's actually start on this side over here. Start with this natural log of f of x. Hopefully you remember from the videos earlier on in the playlist on logarithmic differentiation, what happens when we differentiate the natural log of some function f of x. And hopefully you remember that what we get when we differentiate it, and hopefully you could see when we did the examples of differentiating natural log functions, what we end up with is the derivative of f of x, so f prime of x, divided by the function itself, divided by f of x, right? And this is going to be the general form. This is going to be the general form of when we find the derivative of all these terms within this expression. But at the same time, it's important to realize that this is actually going to be what the left side of our function is, right? We've got f prime of x, which is actually what we're looking for. We've got f prime of x divided by the function itself, divided by f of x, right? So that's the derivative of our left-hand side. What's the derivative of 8x? Well, it's just 8, right? Just 8 times x, its derivative is just 8. So now, what do we do for this expression? We've got a half, which a half can actually just kind of come along for the ride in front of this expression we've got. And remember, the form that we're going to be following when we take the derivative of these natural log functions is we have the derivative of whatever the function is. So we have f prime of whatever our function is that we're dealing with, whatever we're taking the natural log of, divided by the function itself, right? So we've got f prime of x divided by f of x. So in this expression right here, what is f prime of x? Well, it's just 7, right? Because the natural log, if we said our f of x was just 7x plus 12, what's the derivative of 7x plus 12? It's just 7, right? And then we're just going to divide that by the entire function, by 7x plus 12. And that is the derivative of this term. So hopefully you can see that was, if we were, well, anyway, so that's what our derivative was. And hopefully it made sense by this model of saying that when we take the derivative of the natural log of some function f of x, it's going to be the derivative of that function. So f prime of x divided by f of x. So now the next term. We've got our 9. I'll actually change back to green again. We've got 9. 9 is just our coefficient, kind of just comes along for the ride. And then we've got our f of x. We've got our function that we're taking the natural log of, which is x minus 6. So what is the derivative of x minus 6? Well, it's just 1, right? It would just be the coefficient in front of our x. So our derivative, our f prime of x, is just going to be 1 and then we're dividing that by our function. We're dividing that by x minus 6. So that is pretty much the final form. I should end this video right now because I'm pretty much out of time, and my computer is starting to bog down. I'll do one more real short follow-up video. I don't want to finish this video with my computer all kind of... So I guess I'm going to end here, and in the next video I'll just finish this. It'll hopefully be a pretty short video. So anyway, I'll see you soon.